Welcome to another episode of Sokatoa Part 2. Today we're going to talk about angle of depression and angle of elevation. So right here, I have my beautiful stick man. Most importantly is the eyes. So when you look at somebody, you look at somebody eye level. Okay. And so when we talk about angle of elevation, what does elevation mean? Up. Yes. So looking up from your angle, from your eye level. So this right here, that's your angle of elevation. Okay. That's the most important part of today's lesson. So what do you think about angle of depression? It means you're looking down. Yes, your voices are also recorded on YouTube. So when you're looking down, you are looking down from your eyesight. So your eye level. So then this angle right here is your angle of depression. Make sure you take note of this line right here. This is like an invisible eye level line. Okay, so very important. People always miss that, and then their angle is, they think it's like the whole thing. Okay, so let's do a word problem example. Instead of Kim and Yuri, let's say Prentik and Aryan. Okay, so
this is recorded on YouTube?
Yes, it is. See, that means you haven't been subscribed. So Prentik and Aryan. Aryan. Right? Yeah? Okay. So this is P. This is A. All right. So, you guys live in apartment buildings that are 30 meters apart. Is that true? Yes, okay. The angle of depression from Prentik's balcony to where Aryan's building meet the ground is 40 degrees. The angle of elevation to Aryan's balcony is 20 degrees. Okay, how high is Prentik's balcony above the ground? Okay, so there's Aryan standing at his balcony, and there's Prentik standing at his balcony saying hi to each other, screaming across the street. Okay, so from him looking up, there's that, looking down to the bottom of the door, seeing when his parents will come home, is at an angle of depression of 40 degrees. Okay, so I want to find out how tall this part is. Okay, so based on what we've been doing in class, triangles, right angle triangles. Okay, which triangle would help you find the height of this line? Yep.
So like you can take the angle from the middle line on the second building.
Yep.
The 40 minus, so 90 minus 40, which is 50, and then sine 50 over 30 equals 1 over the diagonal, and then you can find the length of the diagonal, and then you can use the right angle on the second balcony to 1 over the diagonal, and then you can use the 40 to find the other half of the height, and then you can use
Okay.
the other angle.
Okay, so there is a simpler method. So we could, like as you said, we could figure out that this is 50 degrees because it's a right angle triangle. And I know complementary angle, so that's 50. So technically, yeah, you could do this and use the 50 degrees. Or if this length should be exactly same as this length right here.
Yeah.
Yeah. So then you could also use the 40 and the 30 right here to find out that. Both works, whichever way you want to use. So which one wants to? So let's use this. Let's use this. So for part A, I'm just gonna redraw that triangle. So I'm just dealing with one triangle, nice and simple numbers, so I don't get confused. Thank you. All right. So if this is 30, that means this top part is also 30 because the two buildings are the same distance apart throughout the supposedly throughout the height of the building. All right, and I'm looking for this. So let's call it X, for example. So first step in solving anything using SOHCAHTOA. What's my first step? What do I do with this diagram? Ryan? Yeah, so this is hypotenuse, this is opposite, and this is adjacent. Okay, I'm given adjacent, I want to find opposite. So which one deals with O and A? Yep, 10, because TOA. So tangent, do I know the angle? Yep, 40 degrees. Equals opposite over adjacent. Okay, so then tangent 40 degrees is 0.8391. All right, since my variable is on the top, that means I'm simply just multiplying these two. So x equal that times 30, 25.2. Oh, it says to the nearest meter. So when you round it, 25 meters. Okay, so that means Prantique's balcony is 25 meters above the ground. Okay. Now let's see Arian's. Let's see how high up Arian lives. Okay, so looking at what type of triangle have we been doing all this time? Yeah. Right angle triangle. So if I do, I know this is the height of his whole building. All right, but is this a right angle triangle? No. So I'm not gonna take that 60 degrees in the middle. I'm only gonna work with the 20 degrees. Okay, I'm just gonna work with this triangle right here. Okay, that's why I say from the very beginning, your eyesight is what's the most important part. Okay, so that invisible line right there, that helps you create that right angle triangle. So part B, again, I'm just gonna redraw that top triangle to something like this. Right angle, 20 degrees. Let's say I call that Y. Okay. The bottom is, again, 30 meters because the two buildings are 30 meters apart. Okay. Label the HO and A. Opposite, adjacent. So opposite, adjacent, what is it? Tangent again. That's right. So 20 degrees now equals opposite over adjacent. My variable is on the top. That means I'm multiplying them. When you're very comfortable with these, you can just write it all like this to save time. Okay. And then so 20 degrees is 0.3639 times it by 30. You get 10.9. And if we round it, 11 meters. Okay, so does that mean that Arian balcony is 11 meters above the ground? Ryan?
No, because we have to add it to the height of the Prantique's balcony.
Right. So you can see Aryan lives on a higher floor than Pratik. So that means this right here. So it doesn't make sense based on the diagram that says he's 11 meters above. So the 11 was just the red part right here. The blue part was the 25. So that means 25 plus 11. So Pratik's balcony is actually 36 meters above ground. Right? So you added this part with this part, so that means which gives you the whole height. Okay. Based on what we know so far, we cannot solve any non-right angle triangles using when we're only given one. Okay, so that's why we had to break this up into two right angle triangles.
That's why sine law is better.
But in sine law, you need more info. This one, you don't have enough info yet.
Yes, you do.
No. Yeah. Not yet. Next chapter. That's next chapter. You'll do very well next chapter. But this one you don't have enough information to use sine law.
It's like 50.
But you don't know the length of this side or the side.
No, you can't because 50 because like the 30 to the height of the building, that's a right angle. Otherwise, like I guess the building would be crooked.
Yeah, but the right angle, that's why we use SOHCAHTOA. We're trying to do sine law, cosine law when it's not right angle triangle. But if in this case we don't have enough information to use using sine law.
Well, like you have the 50 and the 30.
Okay.
No, we could use sine law.
No, we know that this angle is 60, but we don't know the length of this side or this side.
No.
But you know the 50. You know the length of this, island.
It's 30. Yeah, but that doesn't help you find the height of this using sine law.
I mean, like if you take
Like, so if I'm looking at
you subtract 20 and you subtract 90 and then you use that angle to, you know.
Like if I use sine law on this triangle right here, it doesn't work. I don't have any one length. I know the three angles, but three angles doesn't help you use sine law.
But for the red triangle only, you can use sine
Yeah, but
law.
that's the SOHCAHTOA. So the purpose of sine law, cosine law is to not use SOHCAHTOA on non-right angle triangles.
SOHCAHTOA is overrated.
Okay. So yeah, but if you want to look at it more after the lesson, we definitely okay. This one, example 2. Can somebody read example 2 for us? Pratik, thank you for volunteering.
A theodolite is an instrument used by a surveyor to measure horizontal and vertical angles. Measurements are taken in order to find the height of a cliff on the other side of a river, as shown. Find the height of the cliff to the nearest meter.
Yes. Okay. So you're trying to find the height of the cliff, which is this right here, FC. So instead of somebody standing at the top of the cliff and then dropping a measuring tape down and say, hey, how tall is this cliff? They use these theodolite to measure the angles and then use math to calculate. So right here, how many right angle triangles do you see in this diagram? Yeah, 2. There's actually 2. It doesn't look like it, but yes, this is a right angle triangle. This is a right angle triangle. So one is kind of like on the ground, and the other is in midair. So some of these 3D diagrams, you need to use your imagination. All right. So right angle triangle, that is like a hint. I should probably do SOHCAHTOA on this right angle triangle. So I'm going to just redraw this. Okay, redrawing this triangle right here. This is 75, and this is 52 degrees. Right? This is this right here. C, X, and Y. So which length do you think I should solve for to help me find the height of the cliff? So we can't find the height of the cliff in one step. We need multi-step right here. So going from this triangle, work our way towards solving this triangle. Side Y, right? This right here. Okay, because this will help us get another piece of information for our triangle in midair. Okay, so SOHCAHTOA. This is opposite. This is adjacent. And so guess what? It's TOA again. TOA. So tangent. Every time you set up the equation, make sure you ask yourself, are you given the angle? Yes, I am. So there you go. Opposite is Y. Adjacent, 75. Okay. So again, my variable is on the top, so I know I'm just multiplying. So I could just simply write this. So tangent 52. But when I do it on my calculator, I still want to make sure I do the tangent 52 first. And then times it by 75. I get 96 meters. Okay, so the width of the river is 96 meters. I just found out what XC is. And with that information, I can use it with the 61 degrees to figure out the height of the cliff. So these word problems are not that much harder. It's just that you have to do SOHCAHTOA twice to figure out to do that. Okay, we just solve for the 96. And now we're finding the height. Opposite, adjacent, TOA. Are all word problems going to be TOA? No. But in real life, most likely. Because if I can figure out how long the diagonal is in the real life, I could probably figure out the vertical height or the horizontal height easier. So in real life situation, if you are real stuck on a word problem and you have to guess between sine, cosine, and tangent, guess tangent. Because it's the most realistic. Okay. So this one, tangent 61 degrees equals opposite over adjacent. So when you cross multiply, you get 96 times tangent 61. Okay. When I do it on my calculator, I still do tangent 61 first to make sure I get that decimal correct. And then I'm going to times 96. So therefore, the height of the cliff, 173 meters tall. Okay, so not that much harder. It's just you have to look at the diagram carefully and then figure out how to do SOHCAHTOA once or twice before you get the answer. Okay, so that's the lesson on word problems. Here a few word problems for you guys to try. I would just say that, you guys got the concept. You know how to use SOHCAHTOA. The only trick on the test would be the word problems. So if you practice enough word problems, you should have the good hang of it of how to do the word problem. Okay, practice makes perfect, especially word problems. Okay, any questions? So don't forget to hit like, subscribe, and comment below.